Okay, so we are back again. So now we'll see the representation of an your what you call sinusoidal signal by a phasor, right? So here actually first thing is that our understanding should be clear, such that for solving numericals or for getting ideas, things will be totally clear, right? So let us see how we can make it. So representation of a sinusoidal signal by phasor, if you look into that, all write up is there, we will come to that, but just listen that suppose you have some your what you call that OA is that radius. Suppose OA, suppose this is center of the circle O and this is A. OA represent that your maximum value of a sinusoidal quantity. It may be current, it may be voltage, right? So in the and it is at this position and it is rotating in the your what you call in the anti-clockwise direction, right? So in that case, if you take suppose that vertical projection, so that is AB, let me clear it. Say AB, this is the vertical projection. AB is equal to your OA, it is your sin theta vertical projection, that means AB is equal to, right. So OA is the maximum value of your what you call of a sinusoidal quantities. For example, suppose OA is equal to suppose this signal OA is equal to I, right. This is the current signal, right, I, and say its maximum value, say OA is equal to Im, that is the maximum value of the current, the peak value of the current, right. That means this one is equal to your Im sin theta, right, and this AB is the maximum value, that is your Im, that is OA, right, and AB is equal to Im sin theta, right. Now let me clear it. That means my AB, that is the vertical projection of this, is equal to Im sin theta. Sorry. Now when theta is equal to 0, right, when theta is equal to 0, then AB is equal to 0, then AB is equal to your what you call is equal to 0. So make it a projection when theta is equal to 0. So this is the origin, here it is starting. Now if you take another value of theta, say this angle is theta, for which AB is equal to Im sin theta. So this way you take another point here. Similarly for somewhere here you can take another point here. For theta is increasing, this is the theta, right. Now this way when it will come to some this point, say this OA, when it will come this OA will come here, you will take another point here. Similarly when it will come to this, when theta is equal to 90 degree, that is when theta is equal to 90 degree, then your AB is equal to Im. So take a projection here, this is the maximum value. So if you plot this, it will graph will come like this. Now when you are going beyond this, that theta your what you call more than your 90 degree, then again you take the projection, if the point will come here, theta is increasing, this side this theta is increasing. Similarly when it will come here, right, so further when theta is more than 90 degrees, so somewhere here, so this point will come here. Similarly when it will come here, this point will come here, and finally when it will come theta is 80 degree, again it is 0. And if you take all this point and join it and plot it, it will be a sine curve, that is the generation of the sine. Finally that OA is rotating, so it will come to some position here, this way it will move and it will come to the your how to call that this is 180 degree, then this is 270 degree, and when it will come to this one, it is 360 degree, right. So it is moving like this. So let me clear it. So this is my 90 degree, this is my 180 degree, and this point is 270 degree, and finally this point is 360 degree. So when it is come to this side, when you are coming to this side, so again this value will become negative. So for this point it will be somewhere here, from this point it will be this way it will coming, and finally up to 360 degree if you do, it will be a sinusoidal your what you call generation, signal generation, right. That means this way you take the maximum value of any voltage and current, and then you are moving in the anti-clockwise direction, and accordingly theta is increasing, theta in between 0 to 360 degree, and if you plot like this and your vertical projection of AB is equal to OA sin theta, that is AB is equal to Im sin theta, and if you take each point and plot it, it will give a sinusoidal your what you call sinusoidal signal, right. This is how that sinusoidal representation of a sinusoidal signal by a phasor. That means phasor, actually phasor is a rotating vector, right, because angle will lie in between 0 and 360 degree. So, and it is moving your either here we are taking anti-clockwise, either clockwise or anti-clockwise whatsoever, that phasor is a rotating vector, right. That means voltage, when we write this way, suppose V arrow, I arrow, this is actually phasor quantity, right. But impedance, let me clear it, but impedance when you write Z is equal to, later we will see R plus Jx, right. So, impedance as you put Z bar, right, impedance is not a phasor quantity, we will come to that why it is not a phasor quantity, but voltage and current and phasor quantity, and phasor is a rotating vector, right. So, this is what, that sinusoidal generation, and everything is given here, omega is equal to 2 pi f. So, it is written I am sin 2 pi f t. So, all write up is here, all write up is here for you, but whatever I told this explanation is here, right. So, next is that your this one. Now, we have to here also we have to understand certain things. Write up is here, that is a different, that you read later, but just listen. Suppose I have a current and a voltage waveform, right. So, for this one your what you call this one, actually this one, this is a your what you call the voltage waveform. Now, this inner circle this one, right, this is the maximum value of, say, OB is the maximum value of the voltage magnitude at some time. That means OB is equal to, say, for example, Vm, this is the voltage, say, right. Forget about scale and other thing, that is not an issue. Thing is that we have to understand, and at that time the current, this OA, let OA is equal to, at that time current A position was this time, right, and this angle between this voltage and this current, it is phi, angle is the phi, right. Now, similar way, so I mean this phi, this both are rotating in the your what you call in that your anti-clockwise direction, right, that is omega is given, right. So, omega is equal to 2 your what you call 2 pi f into t, omega is equal to 2 pi f. So, that is your omega is equal to 2 pi f, right, f is the frequency. So, it is rotating in the anti-clockwise direction. Now, if you take the voltage waveform, I mean, and current waveform, suppose when current position, your OA current position was at A and voltage at B, and this phi, and they are moving your what you call in anti-clockwise direction, and omega is given, that your what you call that frequency, right. So, f is the frequency and omega is equal to 2 pi f. So, in that case, as this is moving, when that means angle between B and A, whatever may be the position, angle phi will remain constant. For example, suppose if B is somewhere here and A is somewhere here, this angle phi always remain constant, because both are moving together, let us say, right, and in the anti-clockwise direction. So, because the frequency is same. So, in that case what will happen, that if you make the projection of the voltage from this point, it is some point will be there, when it is coming to this one, this is the your what you call this point, and when it will come to more than 90 degree, it is a peak value Vm, finally it will go and come to 0, and again it will move like this. Similarly, when your OA is the your what you call Im we have taken. So, at this point this is the your what you call the theta is equal to 0, right. So, in that case what will happen, that your this point it will start, and in that way that your what you call this current wave will be your what you call this sinusoidal one, voltage also sinusoidal one, but at theta is equal to this time your t or theta is equal to 0, current waveform will start from that, because position is here and voltage will start from here, somewhere here, right. So, this way, suppose this sinusoidal waveform, voltage and current both are generated, but angle between these two remain same. For example, that just this thing, here we have taken the two quantities, one voltage and current, right, represented by OB and OA, everything is written here. Here it is shown that the phasor OB is leading the current phasor diagram. That what is the leading, that what does it mean in mean is leading or lagging, right. So, in that case what will happen, that if you take that V is equal to, first we have to understand leading and lagging, and then we will come to this. So, first let me clear it. Now, question is that what is leading, and you have to see that out of these two waveform, which one is reaching its peak value. Forget about magnitude and other thing, which one is reaching its peak value earlier than the other one. So in that case, this is the voltage waveform. It is reaching peak value earlier before the current, because when it is reaching peak value, current is here. So first voltage actually reaching its peak value before current, because current is here. This is one thing. Or other way, that which one is coming to the zero first, the voltage is coming to that your what you call the zero first compared to the current, right. So two ways can be done. If that out of these two waveform, in this case that voltage peak is you are reaching first, then the current peak, that means voltage actually leading the current. Or other way, that voltage actually coming to the zero first, then the current, that means voltage is your what you call leading the current. And this angle phi, actually this is the angle phi, right. This is what between this voltage and current, this is angle phi, or the peak difference, this difference is phi, right. So leading means you have a suppose voltage and current waveform. If voltage is reaching its peak before then the current, that is voltage is leading the current, right. Or if voltage is reaching zero before the current, that is voltage is leading the your what you call current. Other way, that current is you are reaching peak later than the voltage, that is current lags from the voltage, or current reaching to zero before your what you call after your voltage becomes zero, or current lags from the voltage. So either this distance is phi, or peak to peak this distance is phi. This is the concept of leading or your what you call leading or your what you call lagging concept, right. So in this case, what will happen, that as voltage is leading by this angle, your what you call current phi, right. So if we take the, let me clear, if we take this is my current signal, that means my V is equal to, right, Vm sin omega t, right. This is your what you call this current signal sin omega t, right, and your theta is equal to omega t. So Vm sin omega t. Therefore this is the your what you call that current signal. But in the case of voltage is leading by this angle phi, this is let me clear it, this is not voltage, this is current, right. This current Im is equal to, I wrote by mistake voltage. So current is equal to your I is equal to Im sin omega t. So this is that your waveform of the current, right. Now voltage case, voltage is leading this current by phi. So voltage case we can write V is equal to Vm sin omega t, right, plus phi, right, because theta is moving like this from this position to that position. So it will be sin omega t plus phi, because voltage is leading the current. So phi angle should be positive, right. So we can write Vm is equal to sin omega t plus phi. That means in phasor, if you make it like this, in phasor, suppose we are writing I is equal to Im sin your omega t, right, this we are writing. So that means my RMS value is actually Im by root 2, this is the RMS value of the current, right. That means when we write this your what you call, this is my RMS value, that means we can write, let me clear it, we can write I is equal to say Im by root 2, right, and angle 0 degree, because I is equal to your Im sin omega t, nothing is there with that. So you can write this whenever we write such things, we write I is equal to Im by root 2 angle 0, and throughout this little bit initially I have made an arrow here, this to represent the phasor quantity, is equal to, we can write it is I angle 0 degree. So no arrow is here, means this is the magnitude and this is your RMS value. That means when we write I is equal to Im by root 2, it is RMS value, right, we have seen before, and its angle is 0 degree. So I is equal to, say if we write I angle 0, sometimes we are writing small I or capital I, it does not matter, this is your I, right. Now in the case of voltage we are writing V is equal to Vm sin omega t plus phi, right. So this one we can write in phasor notation, say V arrow. Arrow means it different way it can be represented, but putting arrow, V arrow is equal to RMS value is Vm by root 2, right. Then angle should be, or what you call angle should be phi, because it is leading by this angle phi. So angle should be phi. So that means this one actually can be written as V angle phi. V is the RMS value, but no arrow is here, it means RMS value magnitude. So V is equal to Vm by root 2, the RMS value, right. Whenever we will solve numericals, unless and until it is specified, we will take the RMS value. So, this is actually V angle phi, right. Now, question is, let me clear it, that means my I is equal to, if it is I, right, angle 0 degree, and my V is equal to my V angle phi, then if we plot the phasor diagram, now you draw vector diagram, but phasor is a rotating vector, that is the only difference we have to see. So, if you draw this, so if we make it, suppose this is my I, this is my reference line, the angle is 0, but this is my I and this is V angle phi, so it will be my V, right, and it will be my I, and this angle should be, or what you call, this angle should be phi, right. That means V actually leading the current I by angle phi, or other way we can write, if you take the V as a reference, let me clear it, otherwise this is my V and this is my I, right. So, in this case it is also phi. So, same thing, say if when we are drawing, when we are making this one I and this is my V and this angle is phi, right. So, what we are doing, bringing, you just rotated this one by angle phi. So, V will come to this and I will move. So, again I is lagging, here also I lags V by phi degree by an angle phi, or V leads your I by phi. Same thing here also, V is leading I by phi, or I lags from V by phi, right. So, this is the idea of your what you call leading and lagging. So, that means if you have two waveforms, you have to see which one is reaching its reaching its peak fast, that quantity is leading the other quantity, or which one is reaching to 0 before the other one, that quantity is leading, or vice versa, right. So, this is what all write up is here. I hope you have understood this, right. So, things are very simple. Looking at the figure, this is notes only, little bit closely written for next 3, 4, 5 pages. After that, I have made it this thing, but everything is written here, leading, lagging, whatever I say, everything is written here, right. So, this is the concept for leading or lagging, right. So, that is why here we are making another thing, that I mean whatever I told there in this diagram, that means if we make that it was V is equal to V angle phi and I is equal to, I told you, I angle 0, right. So, this will V is leading your what you call leading your I, or I lags from V. This one also one can write it, if we take V is equal to V angle 0 reference, then I will be your I angle minus phi, right. This thing and these two things are same. Here also V, if you put same thing, it is I angle 0 degree, I lagging from V by phi degree, or V leads I by phi degree. Here also V take reference, V is leading I by phi degree, or I lags from V phi. So, same way it can be written. So, that is why here it is taken Vm sin omega t, just for your understanding. In that case, current will be your Im sin omega t minus phi instead of plus phi, right. So, this is the idea of your what you call that your leading or lagging concept. So, same thing here, the current as a reference phasor, I gave you all these things, there I took small, but here it is taken capital, does not matter, right. So, this is V, this is I, and this is voltage as reference phasor, that here same thing, that V is leading I by phi, or I lags from V by phi, and here also V is leading phi, or V, or what you call I lags from V by phi angle. This is current as a reference phasor, here is voltage as a this, because voltage here is taken as a reference phasor and here current is taken as a reference phasor, but meaning is same. When you will do the numerical also, everything will remain same, there will be no change, right. So, this is the concept of lagging and leading of voltage or current, right, and generation of sinusoidal waveform. Okay. Next, now this is from your what you call from your vector your analysis from your higher secondary physics. You know all these things. Suppose your addition and subtraction of two phasor quantities, the way you do vector, same way you do here also. Suppose this is my V1, I want to add your, this is my V1, it is angle theta 1, and this is my V2, angle it is given theta 2. So, VA is equal to V1 plus V2, arrow is given to represent its phasor. So, your what you call the way you do in the your what you call that vector analysis in your higher secondary physics, same thing, right. So, similarly, and this line is a horizontal line is a reference, here also it is reference, here is subtraction, right. So, this is your what you call my resultant is say this is V stands for addition, and here Vs stands for your subtraction. One arrow is missing, but anyway it is Vs, right. So this is your V1 and this is your V2, right. So if you want to find out what will be your Vs, so you can easily find out that Vs is equal to your V1 minus your what you call V2, right. So in this case, one way it is made, if this is V2, this side will be minus V2, right. That means now if you go for phasor sum or the way you do vector sum, so Vs will be equal to your V1 minus V2. In other way if you do, this is V2 and this is also, this one also you can take V2, this parallel to this, right. Therefore Vs is equal to V1 this direction and arrow is here, so it will be minus V2 either this way or this way. So the way we do, same way we can do, right. In vector same way we have to done, but just cannot be algebraic sum, right. It will be phasor sum. We will see that later when we will take the numerical, right. Now phasor as complex number. So there are three equivalent notation of a phasor. You know the complex number you have studied in your higher secondary mathematics, right. So one thing is that polar form, I mean first thing is the polar form. If you write V is equal to V angle theta, where V is the magnitude and theta is the angle, we can write that V angle theta, right. Now in rectangular form, if you write, it will be V cos theta plus J V sin theta, right. So and another thing, exponential form, that V is your arrow you have given, that V e to the power j theta. V is the magnitude, e to the power j theta, and e to the power j theta is nothing, it is your what we call e to the power j theta is equal to cos theta plus j sin theta, right. And it is written here, e to the power j theta is equal to cos theta plus j sin theta, then 1 angle theta, that is angle theta basically. So now another thing is that we will come to that later. So another thing is that the operator j produces 90-degree counter clockwise rotation, right, of any phasor to which it is applied as a multiplying factor. Actually, hence j square is equal to minus 1. So the operator j produces 90-degree counter clockwise rotation of any phasor to which it is applied as a multiplying factor. That means j square is equal to minus 1. So this is your x, this is real axis, this is imaginary axis, right. So in that case, if this is j, this is your, we call it is imaginary, this is j. When you come to this, just hold on little bit, let me move upward, right. So in this case, just hold on. So in this case, your this is j. Now when you are moving further, it is j square is equal to minus 1. When you will come to this j cube is equal to minus j, because this one actually j square into j. So j square is equal to minus 1 is a complex quantity. So that is minus j, and when you finally you come to this point j to the power 4, so it will be something like 1, right. So it is moving your what you call your counter your what you call anticlockwise direction. So this is this one, and this V cos theta, if you take, this is x component is V cos theta. So V cos theta here is equal to say Vx, and V sin theta is this one. So it is this one you take Vy is equal to V sin theta, and this is the resultant one V. So basically V will be your V cos theta plus JV sin theta, right. So I mean this is your what you call that we V is equal to, every time arrow and arrow is there, I am not telling it, it is understandable, is equal to Vx plus JVi also, right. So the rectangular form of expressing a phasor is convenient for addition or subtraction, right. I mean when you make the rectangular form, I mean this form, right, this is a rectangular form, this form, because for that addition and subtraction will be helpful, right. That polar form, that means this one polar form is convenient way to display two parts of a phasor, namely its magnitude and phase angle, because this V is the magnitude and angle your theta, right, magnitude and angle. So let me clear it, right. And from your higher secondary mathematics, right, you know the operation of complex number, right. So here suppose V1 is taken is equal to V1 e to the power j theta 1, it is V1 arrow, V2 arrow is V2 e to the power j theta 2, then if you multiply this, it will be V1 your, I am writing here if you multiply this, it is V1 e to the power j theta 1 into V2 e to the power j theta 2, right. So, it actually it is V1 V2 and then e to the power j theta 1 plus theta 2, right. So, that is actually what is written here. This one can be written as V1 angle theta 1 plus theta 2, right. That means any angle theta can be written as e to the power j theta, right. So, here let me clear it. So, here angle theta 1 plus theta 2 is equal to e to the power j theta 1 plus theta 2, right. So, that is here, this one is equal to written as this one, right. That means let me clear it, that means this one is equal to V1 V2 in bracket I write cos theta 1 just for your understanding plus j sin theta 1 plus theta 2, right. So, this way you can write. So, this is actually the way we write. V1 and V2 are the magnitude, right, and theta 1 theta 2 are the angles of V1 and V2 respectively, right. So, similarly let me clear it, similarly V1 by V2. So, here I am making it V1 by V2, that is e to the power j theta 1 by e to the power j theta 2. So, it is division. So, e to the power j theta 1 minus theta 2, right, that is your, and it is your V1, here it is V2, right. So, that means it is just hold on, that means this one is equal to V1 by V2 e to the power j theta 1 minus theta 2, that is what is written here, right, what is written here. And again angle theta 1 minus theta 2, that means this one it will be V1 upon V2, then in bracket cosine of theta 1 minus theta 2 plus j into sine of theta 1 minus theta 2, right. So, let me clear it. So, now some caution I have written, some caution is written here. So, in AC, right, work all operation of voltage and current should be done keeping in mind that those are phasor quantities. So, algebraic manipulations are possible only after expressing them as complex quantities, right. So, when you do the calculation, be careful about that. So, that is all. And next is that your, for example, that add the following current as wave as phasor, right. So, in this case I is equal to you have taken 5 sin omega t and I2 is equal to 10 sin omega t plus 60 degree. Now, if you add right I1 plus I2, it will be 5 sin omega t plus 10 sin omega t plus 60 degree. So, 5 sin omega t is there, it is 10 sin your sin a cos b cos a sin b you expand. So, it will be this term. So, after simplification you will get it is 10 sin omega t plus 8.66 cos omega t. Now, what you will do, this actually this one, this 10 and 8.6 you find out 10 square root over plus 8.66 square, right, that will give 13.23 say, right. So, that then divide this your what you call this quantity by 13.23 and multiply. So, if you do so then this one, if you do so, you 10 by 13.23 sin omega t plus 8.66 13.23 cos omega t into 13.23, right. So, that means this one is 10 and this one is 8.6. So, this is 13.23 and this is alpha, that means cos alpha is equal to, assume that your what you call this 10 by 13.233, that is why it is written cos alpha. So, I am writing for you cos alpha is equal to 10 by 13.23, right, and sin alpha here I am writing is equal to 8.66 by 13.23. So, that is why here this one is replaced by cos alpha and this one is replaced by sin alpha, right, and this is multiplied by this 13.23. So, it is sin a cos b plus cos a sin b. So, that is 13.23 sin omega t plus alpha, that is 13.23 sin, it is 40.9 degree, because if cos alpha is equal to 10 by 13.23, alpha will be 40.9 degree. So, let me clear it. So, this is alpha is equal to 40.9 degree. This is one way. Now, this is the peak value, this is the peak value say, right. If this is the peak value, just let me clear it. So, now this is the peak value. Now, this one if you think that your RMS value, this is the peak value. So, when you do it this thing in RMS value, so I1 I am writing for your understanding I1 RMS. should be is equal to 5 by root 2 ampere, right, is RMS value. Similarly, for this one you do that I2 should be is equal to the RMS value, your 10 by root 2, only magnitude you are putting, this is the ampere, right. So, it is 10 by root 2 ampere, 5 by root 2 ampere and 10 by root 2 ampere. Now, in this case this sin omega t means there is no angle associated, that basically it is omega t plus 0 degree, right. That means I can write, let me clear it, that means this one I can write, say I1 is equal to, when we put RMS value 5 by root 2 angle 0 degree, right. And similarly here angle 60 degree is attached, that means I can write I2 is equal to 10 by root 2 angle 60 degree, because 60 degree is there, right. That means this I2 actually leading I1 by 60 degree, because angle is positive 60 degree, right. That means, so this is your how when you solve the, unless and until is stated, if anything term attached with this sine term, that means it is a peak value, you have to divide it by root 2 to take the RMS value, because all our calculation will be based on, later you will see only on RMS value, right. So, in this case that your this one, your this diagram, that is why it is your I, this 5 by root 2 angle 0, that is why it is the reference one. Another one I told you 10 by root 2, this one, this is 10 by root 2 and this 60 degree, this 60 degree, right. So, another way of getting it, so it is taken in RMS value, and this is resultant one, it is 13.23, this is the 13.23 by root 2, because here also it is 13.3 and its RMS value, its RMS value actually 13.23 by root 2, right. This is the magnitude and its angle is 40.9 degree. So, this angle is 40.9 degree. So, this resultant current actually leading this one by your 40.9 degree, and I told you I2 is leading this angle by your this thing, what you call this I1 by 60 degree, right. This is actually your phasor diagram, this way it is a phasor diagram for this one. Now, if you take a projection on the your x axis, right, so it will be, this is reference, so 5 by root 2, actually everywhere root 2 will come, that is why this root 2 is taken outside, right, plus this 10 by root 2 is outside, and cosine of your 60 degree, cosine of 60 degree, this one and this one, this is x projection on x axis, that is 10 by root 2, if you do it. Similarly, for y axis projection it will be 1 by root 2. So, it is reference thing. So, its projection on y axis is nothing but 0, plus it is 10 sin 60, because this angle is such that y axis projection is 10 sin 60, that is 8.66 by root 2. Now, sum if you take, resultant will be root over sigma x square plus root over sigma y square. So, that is 1 upon root 2, it will be root over 10 square plus 8.6 square, it will become 13.23 by root 2. Whatever it is written here 13.3 by 22, and alpha will be tan inverse your what you call tan inverse your sigma y upon sigma x, that is tan inverse 8.66 by root 2 by 10 by root 2, right, and that is equal to 40.9 degree. So, whatever we have got here, right. So, I is equal to similar way, that 13.23 sin, this is the maximum value 13.23 sin omega t plus 40.9 degree. This phasor diagram is drawn, that is why RMS value is taken, right. For phasor diagram you should take RMS value, not the maximum value, both way it is shown. Thank you very much, we will be back again.